Hello everyone. Today we will learn about rolling motion. So first we will find the kinetic energy of rolling motion. Now let us consider a sphere whose mass is m and radius is r. So this is sphere whose radius is r, its mass is m, is now rolling on this plane surface where omega is its angular velocity and here v is the linear velocity. So here is a sphere whose mass is m, radius is r, omega is the angular velocity and v is the linear velocity. In case of rolling motion, first we have to understand when the body, that object, is rolling, at that time it is having two types of motion. One is a translational motion and another one is rotational motion. So to find the kinetic energy, here the kinetic energy, the total kinetic energy will be the sum of kinetic energy of translational motion and kinetic energy of rotational motion. So the total kinetic energy will be the sum of kinetic energy of translational motion plus kinetic energy of rotational motion. So the basic formula for the kinetic energy of translational motion, that is 1 by 2 mv square, and for kinetic energy of rotational motion, that is 1 by 2 I omega square, where I is the moment of inertia of the given body. So now we have to find the total kinetic energy. Let us consider here I, that is I means moment of inertia, which is mk square, where k is the radius of gyration, and we know the relation between linear velocity and angular velocity, that is v is equal to r omega. From that equation, so omega is equal to v by r. So we have to find omega square, so it will be omega square is equal to v square by r square. So now by putting these values in above equation, so here the kinetic energy, this equation now will continue, 1 by 2 mv square plus 1 by 2 the value of I, that is mk square, and now we have to put that omega square, that is v square by r square. Now here 1 by 2 mv square is common, so by taking common 1 by 2 mv square, so here remaining is 1 plus k square by r square. 1 by 2 mv square into 1, that is 1 by 2 mv square, 1 by 2 mv square into k square by r square into v square. So 1 by 2 mv square, 1 plus k square by r square. So this is our total kinetic energy when body is rolling on the plane surface. So this is the expression for kinetic energy of rolling motion. Now we have to find the velocity and acceleration of rolling body. Now let us consider a sphere whose mass m and radius r is rolling with angular velocity omega from an inclined plane. So to find the velocity, we have to understand that at initially the sphere is at rest. So its initial velocity u will be 0. So therefore here the value of u, that is initial velocity, is 0. Now here the total potential energy will converted into the kinetic energy because this sphere is now rolling with some speed. So now the total potential energy, that is potential energy, will converted into the total kinetic energy. But we know that here the body is rolling, so therefore here the kinetic energy is translational plus rotational. So the formula for the potential energy, that is mgh. Here translational kinetic energy is 1 by 2 mv square and kinetic rotational energy, that is 1 by 2 I omega square. So now 1 by 2 mv square plus 1 by 2, the value of I is mk square, where I is moment of inertia, omega square is equal to v square by r square. So this equation is totally similar to the last our equation of the kinetic energy. Now we are taking common as 1 by 2 mv square. So 1 by 2 mv square 1 plus k square by r square. So here mgh, that is potential energy. So now here m will get cancelled. So basically we have to find here velocity, means v. So this 2 will go with gh, so it will be 2gh, and that 1 plus k square by r square in denominator. So v square is equal to 2gh upon 1 plus k square by r square. So now we have to find only v, that is linear velocity when body is rolling from an inclined surface. So by taking square root, so we have v is equal to root 2gh upon 1 plus k square by r square. So this is the expression for the velocity of the rolling body. Now to find the equation for acceleration, we know the equation of motion, that is v square is equal to u square plus 2as. Here u is equal to 0. At initial position the velocity is 0. So initial velocity is u, that is 0. So this equation is now v square is equal to 2as. The value of v is v square is 2gh upon 1 plus k square by r square. So here the value of v square is 2gh upon 1 plus k square by r square. So 2gh upon 1 plus k square by r square is equal to 2a. Yes. So we have to just find the a, that is acceleration. So a is equal to 2gh upon 1 plus k square by r square. So these 2's now will come here. So 1 by 2's. So now in this diagram, so sin theta is equal to opposite side by hypotenuse. So here is opposite side is h and hypotenuse is s. So s is equal to h by sin theta. So now we are using this value of s is h by sin theta. So now I am just putting the value of s, 1 by 2 into the value of s is h by sin theta into 2gh upon 1 plus k square by r square is equal to a. So now in this equation, this 2 and h will get cancelled. This sin theta will be now sin theta into 1, that is sin theta, and this g. So sin theta into g will be g sin theta upon 1 plus k square by r square. So the equation for acceleration is g sin theta upon 1 plus k square by r square. So a is equal to g sin theta upon 1 plus k square by r square, acceleration of rolling body.